Okay, thank you for the opportunity to once again give you a briefing that's based on work done by some of my students. Actually it was at last year's annual meeting. In some of the discussions that I gave, the people from the RASDR group came and suggested that there were several things that an academic institution could do to assist in the RASDR project. And we've done several things. I'm going to report today on the last effort that we did in support of RASDR, which finished up, this particular analysis was finished our spring term, which ended basically the end of April. And what it is a strength, weaknesses, opportunities, and threat analysis that in business we call the SWOT. And here are some of my students that participated in it. These are three of the best engineering management students that I've run across, and they did this study as their report, their activity for the Advanced Technology Applications course that they took in engineering management. So in the beginning, Jack London heard the call of the wild in 1903, and Carl Jansky heard the call of deep space in 1931. And you guys are more familiar than anybody else, any other audience that I might speak to. So as we all know, radio astronomy is more available now, more accessible than ever before. Capabilities ranging from the Arecibo that we've been talking about all the way to a relatively inexpensive dongle that you can pick up some things with a $20 or even a $10 dongle now and a computer. But one of the biggest opportunities for amateur radio astronomy these days has to do with the software-defined radio technologies, receiver technologies. Lots of different applications for SDR, but the RASDR group that was partially funded up front by SARA, a grant to do a study, accepted that challenge of designing a state-of-the-art software-defined receiver with specific application to radio astronomy. And it is to be, and still in flux, of course, as you heard, state-of-the-art, customized UHF designed with the special features that radio astronomers might benefit from. This is sort of a chronological series of events, and I won't go through all of that, but it's in the printed report that you might be interested in, particularly some of you who haven't followed it really close. But lots of effort been put into this, and having worked with these folks for over a year now, pretty closely at times, I can say that, as I mentioned yesterday, I've been very impressed with their dedication, their motivation, their interest in not only the radio astronomy amateur hobby, but in providing a service to the members of this organization through developing this new receiver. Now, Florida Tech, as you might know, I've mentioned before, I wear several hats. I'm a full-time professor at Athens State University, but I also teach graduate level coursework at Florida Institute of Technology, which happens to have a graduate extension in Huntsville, Alabama. And since my PhD is actually in engineering, with a minor like in engineering management, I have an opportunity to teach some of the brightest minds that I run across in our geographical area. So we started out in the summer of last year, right after the annual meeting here, developing a preliminary project management plan for the development and low rate initial production of a batch of the RASDR receivers. And we presented that summary report to the RASDR group, and I think it got reported in the SARA journal. Then in the fall term, we did a more detailed project plan, came up with some estimated cost numbers with the help of the group, and did some analyses. So then in the spring term, which is the term that I'm reporting on here, we did perform the strengths, weaknesses, opportunities, and threat analysis, where we compared the current RASDR, which at the time was RASDR 2, evolving into RASDR 3, so to speak, with a lot of other SDR receivers in the current marketplace. And as I said, it's actually a technology commercialization strategies course from an engineering management perspective that this whole thing took place. What is a SWOT? Well, as I said, strengths, weaknesses, opportunities, threat. It's a tool really for decision making at the engineering management level. You enhance the strategy planning and decision making process with a SWOT. And again, it's kind of a 100,000 foot perspective of a project. You explore possibilities for new efforts or solutions to problems, make decisions about the best path for the initiative, identify opportunities for success, but in the context of the marketplace and threats that might serve to challenge or deter the project. Determine when and where and if change is possible, and at that point you define and adjust and refine the plans to enhance your current project. Okay, so I'm going to summarize some of the results along the way here. Again, I want you to keep in mind, and this is mentioned in the report, that the group of students here are doing this analysis almost as a completely removed entity, think tank, you might think, from SARA, because they had not been involved in it. They had no biases in one direction or the other. A couple of them are design engineers, but we didn't ask them to go off and design their own SDR or anything. So they just kind of took a look at it for what it was, you know. Took a duck for a duck, if it appeared to be a duck in their opinion, and reported on that. So in the strengths area, they were looking at characteristics that give RASDR an advantage over similar products in the marketplace. Weaknesses, areas in which the group perceived RASDR doesn't match the best of what's in the marketplace. So these factors included price, performance, where they actually compared some of the system specs of these other things. The utility of the device, is it readily customizable by hobbyists or tinkerers? The hardware agility, in other words, most of all of us like to tinker with something. I mean, we're just not a plug and play group of people, right? It's more like, oh, well, I kind of really want to do it this way. So can we modify it? What about the software agility? Is it reprogrammable, or are you able to modify the software to do something that you might have particular interest in? And then probably the softest part of the whole analysis, of course, primarily because the design and cost of components and stuff are always in a state of flux, was the production analysis based on finances, availability of units, the production plan, and a delivery plan. In the opportunities area, the group looked at company external factors that can enhance the likelihood of RASDR success. And for opportunities, they looked at potential and planned innovations, market niches, new markets. In the threats area, company external factors that might inhibit bringing RASDR to the market or negate its perceived strength. And these types of projects that are in a volatile technology area, one of the biggest risks is the delay in getting a new product to the marketplace. You always face the possibility that by the time you get it there, it's already obsolete. And if you bought a computer in about the last 5 or 10 years, it's almost like by the time you get the thing home and unpack it, there's a new model that offers you more for the same or less price. So this is the kind of thing we're looking for here. Okay, so new technologies, component technology, Moore's Law that Tom mentioned earlier affects that. The production technology, of course, additive manufacturing, which is basically 3D printing, on-demand manufacturing. It's a very competitive field. The marketplace, whether this is an entry item or what, and the environment, what regulations, what about the supply chain, and how might that affect things. Okay, so of an external perspective, we're not solicited. In other words, although the group communicated some with the RASDR team, this particular group, I don't believe we ever had a telecon with, we may have had one telecon as a group, I don't remember exactly. But anyway, the RASDR is not available to consumers yet, although you guys did have the RASDR group had a beta test program going on. Therefore, the user community can't critique based on experience, which is not totally true, because we did have some feedback that's getting incorporated in RASDR 3. Solicitation and collection of survey data was anticipated to exceed the time constraint of the project. So they perceived very early on that, hey, we have 3 months to do this whole thing. We don't have a lot of time to send out a survey of the marketplace and so forth. And again, did not solicit perspectives from the developers. The project team elected to use existing LLC documentation, blah, blah, blah. Something that wasn't presented up front here. In the fall of last year, the Florida Tech team, in addition to that detailed project plan, did form the RASDR LLC as part of the project. That has been sort of turned over now to the RASDR group, put together an operating agreement, all sorts of stuff like that. But that information was available to this group of people. So the data set consisted of general use SDRs. I think the group looked at 19 systems. Basically, David Fields recommended this RTLSDR.com roundup. So the team did help a lot there. Bogdan supplied a lot of the pricing and parts list information. RASDR plus a 5 price point peers in the roundup includes systems priced from 400 to 800. So the group, the RASDR 2/3 version with a group of other SDR receivers in that price range. And I'll speak to that in a minute, but actually some of the recommendations that came out of the fall study, I think, suggested some changes that were being incorporated, which would have lowered the RASDR 3 price probably below the $400 per unit mark. So maybe they consider some others. Performance factors included frequency range, the low and the high, wider's better, analog to digital conversion resolution, bigger's better, instantaneous bandwidth, again, bigger's better. So here's a list of a bunch of the receivers that were looked at. All this data is in the report, and here is RASDR down here. It's not that easy to see, but you see, just generally speaking, and this group is sort of organized from best or highest to lowest, sort of, and RASDR kind of falls in the middle of a lot of these different things. characteristics. And again, this was sort of a hybrid RASDR 2/3 design. Here's looking at the group that made up the price peer group that we were talking about. The ASRP1, the Blade RF, and this was all, I think, before the Lime design came about, or in the time frame. The Red Pit Guy, the USRP, then the Wind Radio, all these were in the ballpark, and again, RASDR at that time was estimated to sort of be in the middle of that bunch. Okay, the methodology, again, open source information was used by the group. Product reviews that were published on this website, rtlsdr.com, made up a lot of the data that was used for the analysis. Some of the assignment of factors, price and performance, are based on the published prices. Utility production factors based on information from the RASDR documentation. Some of the assessments here, the SWOT factors. Again, this is from the perspective of a detached group who looked at it in the point of view as students, non-consumers of SDRs. These were not people that were really familiar that much with software-defined radio technology, so they just, again, kind of didn't have a whole lot of technical insight, so they looked at it and just sort of made their analysis based on what they saw and kind of took it as presented. Non-practitioners of radio astronomy or any other discipline or hobby radio. So none of them were hams, you know, about all they could say is maybe they played a radio before, you know. They turned one on, they recognized when they hear a radio playing, probably. Really sharp people, though, I have to say. So again, they developed some graphs that I'm going to show you briefly here. They also assigned weighting factors, and out of a total of 1, I believe all this should add up to 1 here. The price was rated at 0.4. Frequency low and frequency high were rated at 0.2 each, and the A to D converter and the instantaneous bandwidth 0.1. And again, these things are subjective to a degree, and something that the group did not do was to do a sensitivity analysis to see how varying these factors would have changed their outcome. Okay, so in case you weren't blind up until this point, now you can join me and many others who've looked at some of these and say, okay, I'm blind. Anyway, we're following RASDR here as it fits in. These are all the other receivers that are along here, and these are some of the factors. So RASDR ranked 10th in the middle of the pack here based on the weighting factors and so forth. So didn't really pop out as wow. It wasn't a wow signal per se. It's just, okay, it's in the ballpark. It's competitive somewhat, but not real high. Now on the price point peer group, in terms of price, RASDR was ranked third in the middle of the pack, but remember it was a fairly small pack. Here's the 5 devices that were analyzed, and you see where RASDR kind of fell in here. And again, if you're like me, you might have to stare at these charts 5 or 10 minutes each before it all sinks in, but I'm going to bring you to a conclusion here shortly, okay? Okay, analysis summary. In terms of strengths, price was reasonable. They felt like the price of RASDR at that time, which we know now is lower than it was at the time the analysis was done. Performance was reasonable. The utility, customizable hardware and software because of open architecture design, so there was some utility available there. Portable across Windows operating system platforms, also backward compatibility there. Modular innovation makes it easier, accessible. So those are all strengths. Opportunities in terms of performance, a multi-purpose system that can support a wide range of users. Planetary, deep space, aircraft, weather balloons, satellites, ham, etc., with some tuning, customization of the open architecture. Utility, hardware and software customizable. You could do add-ons, utility to other users possibly. One of the things I know the RASDR group talked about many times was how do we enhance other hobbyists or other users beyond the radio astronomy market to be interested in RASDR in order to increase the numbers. How do we get other people interested in RASDR, which would lower the price for everyone involved? So we're talking about ham radio, the option to transmit or generate a signal output, do some other things. Okay, one thing they pointed out was the opportunity to have a RASDR blog, a RASDR chat room, all these things to generate more interest. Okay, in the weaknesses area, the students felt that there was no real significant discriminators that set the RASDR apart from some of these other devices that were available. Good design, in the ballpark, competitive, doesn't pop out. Doesn't really pop out as a big winner there. Production risks, and everybody who's ever worked on a development project suffers this disease here. Getting the design frozen at the time. Again, this is a communication problem really. They said the bill of materials was incomplete. That's not really exactly correct. Undefined funding source. Vendor and manufacturing agreements weren't fully implemented, I guess. The potential displeasers does not transmit. And again, this is a big appeal to the amateur radio market, although a lot of the software-defined receivers out there obviously don't transmit. Hams are still buying them, right? But a lot of the transceivers have that, okay?
Where did you get that perception? It'll transmit, we just didn't want to.
Exactly.
All right.
Yeah, I know it has the capability, but
it had the capability all along, and anybody
right.
could come along as a ham and make it transmit if they wanted to.
Right.
We wanted a radio astronomy receiver, not a transmit. And Logan probably would disagree with me because he always wanted to transmit.
Yeah, that point is well taken and recognized. Bogdan?
It's incapable of transmitting arbitrary signals. It can only produce a continuous wave signal. So,
Yeah.
Not quite true either.
Okay. I have no fight with that. You guys, that's fine. And again, the students here, these are 3 graduate students that have never met any of you guys and only used the information that was obvious, okay? So that's probably in the documentation somewhere. They didn't recognize it. So peace. Okay, don't shoot the messenger here. Just.
I think the presentation is correct.
Okay. Well, anyway, the threats were okay, and again, the threats are things that would detract from the potential success of the project. Not anything to go jump out the basement window about, but anyway, price was that it was not an entry-level system. How much of the user population are we losing? In other words, RASDR's not a $20 dongle that you can go buy and play with and decide, you know, this SDR stuff is for the birds. I'm not really interested in it. Most of the people that would buy a high-end receiver like that already know what an SDR is and why they're buying it. So, you know, anyway, that's an observation. Production. On-demand and additive manufacturing might make some of the components obsolete, like the case. And of course, the case that they originally saw was the RASDR 2 case, which was fairly expensive. And but at the same time, RASDR 3 had already picked a mass-produced extruded aluminum case that cut the cost to a fraction of what it was. So again, this is just an observation here. So they're saying, okay, well, maybe 3D printing or something could help. And then the market, they recognized it based on what they saw as a saturated competitive field, no room to play in successfully unless they're recognizable discriminators. In other words, if you're going to be successful, you've got to have a design that pops out as, hey, this is a leader. This is what I want for my money type thing. And they just didn't see it on that analysis. And again, you know, they took it, they reported what they saw, not necessarily. Okay, some more observations. Middle of the pack price and performance suggests there are no significant discriminators. And they did have some caveats on these statements. Marketing is the key. Obvious, okay, duh. Got to get out there and push it, make people aware of it. Market entry appears to be later than sooner, more later than sooner, I guess. Again, the technology is evolving so rapidly, and I think maybe Paul and Bogdan will support that with this line. RASDR 4 technology probably wasn't available even at the time this analysis was done. And suggestion says follow the Microsoft paradigm, release the RASDR 3 within the next 3 months, let the user community find the bugs, make suggestions, follow with RASDR 4 within 6 months, blah, blah, blah. That would be fine if you were, you know, IBM or HP or somebody with deep pockets and a 1,000-person engineering team, right, Skip? But, you know, for 3 guys in their kitchen and garage, I don't know if you can expect that kind of thing to work out. Okay, so learn more about, these are some things that what consumers want. And they were suggesting, okay, we know what the radio astronomy group want. What about canvassing the whole marketplace of SDRs and find out what they want as a whole? And I think that's what's happening with the line thing, so maybe that's a good deal. What technology are looming in the near and very near future? How would cost, performance, and speed to the market be affected by innovations to materials, components, manufacturing, and programming? Are there any disruptive innovations on the horizon? Could be a serious question. And again, what can RASDR leverage? In other words, make a threat into an opportunity. And I think maybe in RASDR 3 and the new RASDR 4 concepts, that kind of thing's being done. Okay, so here's some of the references and credits that they recognize and gave. And again, a lot of information out there, and couldn't have been done without the help of the RASDR group. And again, this report is not meant to be derogatory to anyone involved in the project. It's just sort of an independent review of what it looks like to them. And so take it with a grain of salt. And this and $5, you can buy something at Starbucks.
Another 5.
Yeah, exactly.